A compound contains 31.91% potassium, 28.93% chlorine, and the rest oxygen. What is the chemical formula of the compound? Given the atomic mass of potassium to be 39, chlorine 35.5, and oxygen to be 16. Solution. And before we proceed, if you are yet to subscribe, kindly do that so you don't miss out on more videos like this. Let's continue. In the question above, we have been asked to calculate the chemical formula of the compound, whose elements are potassium, chlorine, and oxygen. We are given the percentage composition of each of them except oxygen. First thing first, we are to calculate the percentage composition of oxygen present in the compound. For potassium is 31.91%. Let's state that. Chlorine 28.93%, and for oxygen remains unknown. So taking the whole of the compound to be 100%, then oxygen will then be 100% minus the summation of each of them, so as to know the amount left for oxygen. (28.93) for chlorine, and this is equivalent to 100% minus. Summing this, we have 60.83 in percentage, which is equivalent to 39.77%. If just calculate the percentage composition of oxygen present in the compound, we know that of potassium and we know that of chlorine. This will be making the work very much easier. So the chemical formula would always shows the exact number of atoms of each of the elements present in the compound. And how do we determine the number of atoms present? We can only get that by determining the number of moles of each of the elements in their simplest ratio. Let's continue. So I'll be doing this simultaneously, instead calculating that of potassium separate, chlorine separate, and oxygen separate. To save them, we'll be doing it simultaneously, hence we'll have a tabular form. So we have potassium here, chlorine, we have oxygen. We want to get the number of moles of each of the elements, and for calculating moles is always mass over molar mass, but in this case we won't be dealing with molar mass since we are working with each of the elements, hence we'll be having a relative atomic mass in place of molar mass. So our formula for moles will then be mass over relative atomic mass here in this case. Another thing again to note is that the mass is not given, we're only given the percentage composition. So since we are given the percentage composition, then we can take a percentage of the whole of the compound, which is 100%, to also be 100 gram. So if the whole of the compound is taken to be 100 gram, definitely the percentage of potassium, which is 31.91%, will be equivalent to 31.91 grams. Chlorine will also be 28.93 grams, while oxygen will be 39.77 grams. That is, as we have them in percentage, they can also have equivalent values in grams if we are taking the whole of the compound to be 100 grams. Explaining that as a mass, so we won't be confused when we are working with the formula for calculating moles, which is mass divided by the relative atomic mass. So here I can just say percentage composition by mass. For potassium here I have 31.91. For chlorine I have 28.93. And for oxygen I have 39.77. So the relative atomic mass for Potassium is given to be 39. Chlorine is given to be 35.5, while oxygen is 16. To get the number of moles now, that is the amount, we have 31.91 divided by 39. We have 28.93 divided by 35.5. And we have 39.77 divided by 16. So this will be giving us 0.82. Dividing this, we have 0.81, and there we have 2.49. Now we won't be stopping here because we are winning the simplest ratio. To get the simplest ratio, we will be dividing this by the smallest values. Now the simplest ratio is needed so as to also have this in whole numbers instead of the decimal values we are having here. So here we have the simplest value, that is the simplest amount, to be 0.81. So dividing by the smallest, here we have 0.82 divided by 0.81, 0.81 divided by 0.81, 2.49 divided by 0.81. Dividing this, we have 1.0. For chlorine also 1.0, and for oxygen is 3.1. The simplest ratio in which they combine will then be 1:1:3. Since this is less than 5, then approximately will be taken to be 3. It was given the chemical formula of the compound to be okay. This should have a subscript of 1, that is the number of atoms of potassium present here, but writing the 1 will be insignificant, so we'll just leave that. But we do know it is 1 that is present here. Same thing for chlorine, and for oxygen the number of atoms present is 3, so we have the formula to then be KClO3, which is the final answer. That will be all. Do not forget to subscribe and as well click on the notification bell so as to be notified as soon as new videos have been released. You can as well leave your comments in the comment section below. Thank you.